7-7 in Advanced Algebra 2, you get a nice little story to start us off with. We know that symbol right there is pi, and you should know by now that that is really a number, right? It is a number that the mathematicians, the Greeks, and all those people way back in the day figured out is really the ratio of the circumference to the diameter of the circle, right? They figured it out. It is a nasty, irrational number, so they made up a symbol for it instead. Well, there were some really smart mathematicians by the name of Leonard Euler and John Napier. Euler, I know it looks weird, but it's pronounced Euler. He's the guy that's really credited with coming up with another weird symbol called E. E is like a natural number, something that occurs often in nature. This old boy, Euler, did tons and tons of experiments. And he figured out that this number, 2.71828, blah, 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 just kept showing up naturally in these real-life problems. Just like that weird number of 3.14159, you're like, oh, that's a weird number, Here's this other weird number. Since it was irrational, he came up with the symbol of E for it. Well, that's the base in our natural logarithms. If I wrote this, what is the base in that situation? This is a common logarithm because it's base 10. Well, since E happened so stinking naturally, they said, hey, man, and it's an exponential situation most of the time, it's like, why don't we come up with a whole new logarithm that has E for the base normally? So they didn't want to write log base E of 5 or anything like that. They just said, why don't we call it a natural log, right? Like a natural logarithm. Since E is such a natural number, they just say ln, where the N stands for natural and the L stands for logarithm, right? So ln. And you can even see that that's right below your logarithm button on your calculator. Isn't there an ln button, correct? Look right above the ln button as a second function. What does it say right there? E to the x, right? E is on your calculator. So if you wanted to figure out what E actually is, let's hit second E, right? You have to hit that natural log. And it always puts an exponent to you because that's what you use E for. You got to take it to a power. Well, how do I figure out what E is? What power would I have to raise it to figure out what E is? To the first power. That 2.7182, meow, 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 meow. There's that number right there. It's the number E. So realize whenever we have an E in our problems, we don't want to use regular common logarithms. We would much rather use natural logarithms. Okay? So let's dive into some problems right here. Evaluate these logarithms to the nearest 10,000. Well, natural log has base E every time. Do we have a natural log button on our calculator? Yes, we do. So we can punch this straight into our calculator, if you give me a second here. Natural log of 12,492. Rounder to the nearest 10,000th. About 9.48. Groovy? On the next one, people are like, hey, should you condense those logs if you want to? They're still logs, right? And a lot of times you'll actually hear me say it as log, and I apologize because once you get further in mathematics, you kind of never use the LOG. You always use natural logs. So I might actually accidentally call this log, but we'll call it natural log. Cool. But do I need to divide the arguments? You can if you want to, right? You could say, well, I'll take the natural log of 493 divided by 181, but why not just punch natural log of 943, close the argument, minus natural log of 181. Either which way, since they're equivalent, should get you the same answer. So that is about 1.65006, right? Try the rest of them. Punch them all in. So here's what we should have got on all these bad boys. Check yourself before you wreck yourself. All the same rules of logarithms apply. It says write a logarithmic equation equivalent to the following. So this is exponential, correct? Isn't the x up in the exponent? They want us to write it as a logarithm. But my friends, what's the base of these problems? E. So don't use log, log. Use natural log instead. So the natural log of the argument, what's the argument? 7 equals the exponent, which is 2x. And notice you don't want to put this right there. It's understood that e is the base when you use natural log, so don't have it, right? If you had to write it the other way, it has to be this. These are the same stinking thing, but this is very immature mathematically because they created an entire word called natural log to stand for this, of log base e. So how about this bad boy right here? Since e is the base, it's the natural log of the argument, which is what? 10x equals the exponent of 8.2. We're not solving for x. All they asked us to do was rewrite them, going back to square one with our logarithms, except these are now natural logs. Then they say write these in exponential form. They used an approximate symbol, so we'll use an approximate symbol. So we want to write it in exponential form. What's the base? E is the base. What's the exponent? It's this 0.3345. And then since they use an approximate, I'll use an approximate of the argument right there. Give number 10 a try real quick. Rewriting it exponentially. Yeah, e to the x equals 42. Cool. Awesome. Your turn. All 6 of them, right? Do what they tell you. Write an equivalent exponential or logarithmic equation. Get all 6 of them done. If they give it to you exponential, rewrite it logarithmic. If they give it to you logarithmic, rewrite it exponential. Same thing we just did. You can check yourself out there in video land. That's what these puppies are supposed to be. Now, let's continue. Simplify these. Same basic rules of logarithms. Aren't they subtracting this situation, right? And you got a number in front of a natural log. Doesn't he come up as the exponent right there? So I'm going to do a 2 for 1 special. 10 to the third is 1,000, right? And the natural log has not disappeared yet. Minus natural log of 8. Cool. Now, since they have subtraction going on, I will take 1,000 divided by 8. 125, right? So the natural log of 125 is what that is. And then you got to ask yourself, can that clean up? Is e to any power turn out to be 125? No. The things that'll clean up nice is if this has an e with it still. Right, so I kind of skipped over that at the beginning. Let's go over that at the beginning. Oh, I cut that out. So, like, what do you think the natural log of e would be? Remember, if you're not sure, you got to rewrite it. Let's call that x, and isn't this really the base right there? E to the x equals e. What does e have to equal? Or, sorry, what does x have to equal? 1. Isn't the natural log of e turn out to be 1? Y'all cool with that? What about if I did stuff like this? All right. Well, we could go back and rewrite it exponentially. E to the x power equals e to the second power. What does x have to equal? 2, right? The ones that are non-calculator, if it's natural log, there will be an e involved in the argument somewhere. You know that? Cool. All right, next one. Natural logs again. Let's do some condensing. First of all, this is natural log of, here's how I'll do it. I need to do what with all of these arguments when we're adding them together? Multiply them together. So watch this. I'm just going to take that 40 and take it times. Doesn't this need to come up right here? So if I can do that mentally, I will. If I don't know that mentally, I'll write it out. But 1/2 squared is how much? 1/4. And here's a whole other argument right here. Doesn't it need to be multiplied together also? I just kind of made it simple for myself. I knew I have to multiply all the arguments. Well, I want to see them all before I multiply them. Cool? 40 times 1/4 is how much? 10, and there's an x with it also. That's really the natural log of 10x, because you had to take the argument of 40 times this argument, which is really a 1/4 because the squared happened, times the x. Yep. The question was asked, how come we still have a natural log in this when all of these terms have a natural log with them? This is not an equation, is why. We're not solving for anything. We dropped the logarithms. Like if I had natural log of 7 equals natural log of 3, do you see how there is an equation involved with here? I should put an x there, sorry. Natural log of x, right there, you know? Do you see how this is an equation? If there is an equation with every term that has a logarithm in it, you can solve for the missing by saying, well, I can get rid of the logarithms and say x has to equal 7. You can't solve for x in this situation because it's not even an equation in the first place. You're just simplifying it. Cool? Next one. This is really natural log of 25. Now, do you see how we got addition and subtraction in the same deal? So that note tells me I need a fraction, right? Where's the 25 go? Up or down? Up. Then plus this 2 to the 4th, which is really 16, right? If you want to just kind of sketch that out right there, this is really 16, 2 to the 4th. Where's that got to go? Up or down? And shouldn't it be multiplied in there also, right? Minus, so that means that this argument goes downstairs. Cool? And then there's one other thing that needs to be in there. He's going downstairs, right? And what goes downstairs? 3x or x cubed? X cubed. You all comfy with that? Yep. All right. So now we got to clean some of this up. You could multiply 25 times 16 if you wanted to first, but I can see something that I can reduce right away. Do you know what 25 over 5 would reduce to? 5 over 1. So doesn't that become a 5 and that becomes a 1 right there? Now I'm just going to take 5 times 16. The natural log has not disappeared because this is not an equation. This is just an expression. And you've got 5 times 16, which is 80. Is that right? Over, I'm a fan of putting x first and y second, but if you had y times x cubed, it wouldn't hurt my feelings. But I like to put them in alphabetical order. One more, baby. You and pal, get that puppy done. What I did is above this problem. I just kind of figured out what all these arguments really are. I brought the 7 up and called that x squared. I brought the 2 up and called that y squared. That's a z. I brought the 3 up and 5 to the 3rd is 125. Then I put them all in the right place based on what sign was in front of them. Feeling good with those? Yeah? All right. Solving. Same thing as before. Talk yourself through it. There are logarithms involved in this equation, correct? Does every term have a logarithm with it? Too many of you are sleeping on me. This has a logarithm with it. Does every term have a logarithm in it? Nope. So our idea is to get it to be log equals number. There's things you can do with this 3. You could bring him up here, but you could get rid of him a whole lot easier because isn't this a times 3 in front of the log? How could you get rid of that times 3? If we divide both sides by 3, this would be the natural log of 4x equals 24 divided by 3 is how much? 8. All I did was get rid of that times 3 in front because it was one log, right? That's just one term right there. It wasn't like a log plus another log or anything that needed to be condensed first. I got rid of that times 3. Now, it's log equals number. How do we deal with these? What did you do when they were LOGs instead of LNs? What did you do? You can't drop the logs. Why can't you drop the logs? There's not logs on both sides. Where's the x at? Is it in the argument or is it upstairs? It's in the argument, right? There's a way to get the argument all by itself, though, is to do what? Rewrite it exponentially. What's the base? E is the base. right? E is the base because it's a natural log. What's the exponent, baby? 8. That should equal 4x. You see, that's how you get the argument by itself. When there's a logarithm, you need to rewrite it exponentially. Is x all by itself before we go further? Nope. What would you need to do to get x all by itself? So x equals e to the 8th over 4, baby. Right? That's the exact answer. It says that up here. Find exact answers and answers rounded to the nearest 10,000. There it is exactly. Now, let's figure it out. E to the 8th divided by 4. E is located above the natural log button, so e to the 8th. Close that parenthesis because it'll automatically put it there for you. That's the whole numerator, correct? Divided by 4. Let me look. So let's round that to the nearest 10,000th, and x would be about 745.2395. Gribby? You with me on that? See how I just kind of kept it on one line? Let's check it. Where do we substitute it back in at? To the original? I got a question for you. Do I know if this is even possible in the first place? Isn't this in the argument right there? Did I get a positive number back? So it's possible. It's not extraneous. If you got a negative number back, you did something wrong. Cool? Let's type it in just as 3 times the natural log of, do you see how it automatically put a parenthesis for your argument? 4 times that previous answer, close it up, right? Isn't that argument 4x? Right? Now, they didn't have parentheses in the original problem, but it's understood that that's really in parentheses there. You should get back 24, which we did, so check it. Cute? Next. Where's x at? In the exponent. That means we want to get e to whatever the heck that is all by itself. What would you do first to get that all by itself? Add 5 to both sides. So 4e to the negative 2x equals 8. Rock and roll. Divide by 4. E to the negative 2x equals 2. Now that e is all by itself, right, and x is upstairs in the exponent, there's only one way to bring him down. How do you bring him down? We need to log both sides. Now, what kind of log would you choose if e is the base? Regular or natural? So let's natural log both sides, okay? Or you could rewrite this logarithmically, right? You could natural log both sides if you want to, but it's going to be a lot more work. Isn't e the base? And you know those first few 10, 15 problems that we did where here it is exponentially, please rewrite it logarithmically? It's going to be the natural log of, what's the argument? 2 equals the exponent, which is negative 2x. And I guarantee you, if you would have natural logged both sides, which I'll do off to the side, wouldn't negative 2x come in front? You'd natural log this, and that would equal natural log of this, right? But see this right there? That's the number 1. Isn't the natural log of e really 1? Because it's e to what power gives you e, right? It's 1. So that's what ends up happening. I'm saying if e is the base, just go back to very basic logarithmic skills and rewrite it logarithmically. Cool? Now, let's solve for x. What do you got to do to solve for x? Divide by negative 2. See if you can punch it in correctly without me showing you. Get your numerator in there and make sure you closed all your arguments. There's only one term in the numerator and one term in the denominator. That's the exact answer. I'm going to get it approximately negative 0.3466, and then I'm going to check it. So to check it, I go back in, and I'm going to retype the original Broham. I want to just type this left side in and see if I get 3 back when I hit equals. So 4 times e to the negative 2x. Well, wherever there's an x, that's where that previous answer goes. then either get out of that box that you have on your calculator or close your parentheses, one of the two, right, depending on how your calculator is. Still got to do something. What do you got to do? Minus 5, hit equals, you better get 3 back. We got 3 back. Cool. Try again. What would you do, baby? What would you do? Does every term have a log with it? There are logs involved. Does every term have a log with it? Nope. Get it to log equals number. How do you get rid of that 2 in front of there? So natural log of 5x equals 3. Groovy? Now that it's log equals number, do what? Rewrite it exponentially. Go for it. Rewrite it exponentially. Should get that. Then solve for x. Punch her in. We're cool with about 4.0171-ish. Let's check him. 2 natural logs of 5 times that previous answer. Close that up. I hope I get 6 back. Yay, I got 6 back. Rock and roll. Next. Is this logarithmic or exponential? Exponential. Isolate this. Isolate that before you do anything. Isolate that. Right? E to the 2x equals 8/3. Yeah, it's a fraction. Who cares? E to the whatever is by itself. How do you bring that stuff down? Now that x is in the exponent, how do we bring it down? We would log both sides normally, but since the base is e, you could also do this if the base was 10 with common logs. You can just go straight to that logarithmic form. Since the base is e, it's going to be a natural log of the argument, which is what in this case? And that will equal 2x. Cool? And then x equals natural log of 8/3 all over 2. Parentheses are important. Make sure you get 8 typed into your argument correctly. Natural log of 8/3 divided by 2. Natural log of 8/3 divided by 2. Boom. About 0.4904. Check it. Three times e to the 2 answer. Close that up. Plus 2. 10, baby. 10. Yay for me. Try das next one. Well, tell me what you do first, since this is a little different. What's the first move that you got to do? Condense these logs, right? Condense the logs. Ruby, condense the logs. Because there's logs involved, but there's not a log in every term. Regardless, you have to condense the logs. You know that you should multiply those arguments together. I hope you can take 5x times 3x without my help. Keep going. Keep going. Talk with pal. So what's the base? E to the equals 15x squared. Cool. And if you'd talk yourself through it, you'd be pretty good at solving for x. Yeah, it's x squared, but what should we do first? what do you want to do first? Divide by 15 first. E to the 9th equals 15, or excuse me, e to the 9th over 15 equals x squared. Rock and roll? Now that x squared is by himself, what do you do? X equals plus or minus the square root of e to the 9th over 15. Notice the plus or minus. Two answers. Cool? Let's be super smart. Where's x located? Argument. What do you think about this negative answer? Do you think he's going to work? No way, because we've got, so I'm just crossing that out. Mrs. Colwell simplified her radical. She split it up, rationalized it, got rid of all that. I'm cool with this, right? Punch this in your calculator. I realize that this is not the exact answer because you have a fraction underneath the radical. You should split it up, etc. But I want the square root of e to the 9th divided by 15, close it up. I got about 23.2423. Remember, we threw the negative 1 away because we saw it already that it's not going to work, right? The x is in the argument. You can't have that negative number back in there. Let's check it. Natural log of 5 times x, which is your previous answer. Close the argument. Plus natural log of 3 times x. Close the argument. If I hit equals, I hope I get 9. I did. Aha. These story problems, so many students have suffered setting them up in the past that we have decided that we will do these as ideal problems. Ideal stands for this. I stands for identify the question. D stands for define what you know, define all your variables. E stands for write an equation. A stands for act out your equation, solve it, right? L stands for label your answer in a complete sentence. I, D, E, A, L. We're going to cheat. And the I part, we won't do. Okay? It's so much writing that we're asking you to do that we decided to cut out the I part. We're going to identify it in the actual question itself that was written down. Number 27. When Angelina Jolie was born, her grandparents deposited $3,000 into a college savings account, paying 4% interest compounded how much? Continuously. That's the only time you use PERT. Only time you use PERT is continuous interest. Sound cool? Everything else is the compound interest formula from up here. Assuming there are no deposits or withdrawals from the account, what will be the balance in 10 years? Can you identify the question for me? Isn't it right here? What will be the balance in 10 years? Yes? No? First question, have you done ideal problems before? Yeah, you did. In geometry, you should have, with the complement of I. Put an I right there. Identify the question. Put that I step. D, we're running short of time, so I'm going to just motor you through this. D, let's define things we know. First of all, do we have a formula that we will be following? Yep, it's this. The amount equals your principal times e to the rate times time power. PERT. That is the formula we are using. Rock and roll? Let's define everything that we know. First of all, do we know the amount she will have after this situation? Do we know it? So A, we will call the amount after 10 years. That's what A is, the amount after 10 years. So A is the thing we're not sure about. We better know everything else in this formula. P is the principal. What's our principal? So P is 3,000. Isn't that the starting amount that we had? E. You don't define E. Everybody knows E is just a number. What's the rate? What's the rate as a decimal? 0.04. And T is the time in years. Do we know the time in years? 10. Is everyone cool with that? That's all the things to define. Write the PERT formula. Whatever formula you're using, most of these will be the PERT one. Then tell me what all those stand for. E, just keep working straight down. I don't have room to work straight down. E, let's take all of the stuff that we have and substitute it into our equation. We don't know a, so it will still be a. Our principal was 3,000. E is in there. 0.04 times 10 is up in the exponent. Cool? A stands for acted out. So all that E is write your equation. Acted out means let's start solving. I'm going to do this. A equals 3,000 e to the 0.04 times 10 is 0.4. All I did was clean that up and put it right there. So far, so good? I'm looking for A. Is A all by itself on one side of the equal sign? So it's time to punch that in. 3,000 times e to the 0.4 power. This is money, so how are we rounding? 2 decimal places. A equals, I lost it, 4475.47. That's A. Is everyone cool with that? L stands for label your answer in a complete sentence. So there is no abbreviating. They start with capital letters and end with periods. You know who we're talking about? Angelina, right? So let's see what I wrote. I wrote, the balance in the account after 10 years will be $4,475.47. You can write your sentence however you want to answer the question. You could say Angelina would have this in her account, but I wrote the balance in the account after 10 years will be this much, period. To part B, to the nearest tenth of a year, how long will it take the balance to reach at least $10,000? Identify the question. It's right there. How long will it take for the balance to reach at least $10,000? Here's where you're going to love it. Time to start over. D. What formula are we using? A, the amount equals PERT. Now let's define what we know, though. To the nearest tenth of a year, how long will it take? There's your thing that you don't know. When they ask you how long will it take, what's the thing that we won't know? Time, right? Do you know the amount that they want in the account? A equals how much? 10,000. This is the same problem, right? Isn't this just part B of the problem? So principal, do you know the principal? It's still 3,000 bucks. Rate, the rate hasn't changed, isn't it 0.04? Right? And T, we don't know. So that's time in years. Now before we go further, if you don't think that this is a real life problem, now I do know that you probably won't have the continuously compounded interest, but if you don't think that someone wants to know, I got 3,000 bucks at 4%, how long will it take me to reach 10,000 bucks? If you don't think people want to know that in the investment world, you've got another thing coming. Logarithms is how we figure this stuff out. So, we're cool with D, right? People want to know when their money will reach a certain amount. That is so real world you can't even believe it. So let's write our equation. Starts out with A, which is 10,000 bucks, equals my principal of 3,000 bucks times e to the 0.04 times t. Is everyone cool with that? The variable is t. It is in the exponent, correct? The idea is to get this all by itself. This is an exponential situation. What would you do to get that all by itself? Divide by 3,000. 10,000 divided by 3,000 is this. Think about it for a second. 10,000 divided by 3,000, I'll bet you those 3 zeros just cancel each other off. 2. E to the whatever is all by itself, correct? The variable is in the exponent. It's time to either log both sides or realize that our base is one of those nice numbers like 10 or e. Isn't e the base of this exponential situation? So you can just rewrite him natural logarithmically. rewrite this equation with natural logs. The natural log of what? 10/3 equals 0.04 times t. Yes, sir, Bob? How do you solve for t? Divide by 0.04. Natural log of 10/3 over 0.04. This is going to be interesting. Where did you go? Natural log of 10/3, close that argument, divided by 0.04. Do they say round to the nearest tenth of a year? Yeah, up there, to the nearest tenth of a year. So what would you round to? 30 point what? 1. Now, you know what? That might not be good enough. We have to check to see if we will actually have $10,000 after 30.1 years. And we don't get to use this previous answer. We have to use this number. We rounded it. Cool? So let's go back into our equation right here, and we need to punch this in and see if it gets me 10,000 or more. 3,000 times e to the 0.04 times 30.1. See how I used the rounded number of 30.1. Close that up and hit equals. Do we have at least $10,000? So that was good. It will take 30.1 years. Let's put it in a sentence. Our sentence will look like so. It will take 30.1 years for the account to have at least $10,000. $10,000. Part C, if her grandparents want Angelina to have $10,000 after 18 years, how much would they need to invest? Think about why her grandparents would want to wait 18 years for her to have that money. What's so typical about 18 years later? That's when you usually start college. You're born, 18 years later, it's time for college. We want you to have 10 grand when college starts, right? So, what don't we know? First, let's identify the question. When they say how much would they need to invest, what don't we know? What do you call how much we need to invest out of all those variables? Is it the amount, the principal, the rate, or the time? We don't know the principal, correct? So here's identify the question. D, again, the amount equals PERT. The amount that we want Angelina to have is $10,000. The principal, we don't know. So P equals principal. Principal, not principal, I think. I'd have to look that up, honestly, now that I think about it. What's the rate? Still the same problem, right? They're at the same bank, so it's still 4%. And what's the time? 18 years. Our equation, 10 G's equals, I'm not sure, E to the 0.04 times 18. Q. Take 0.04 times 18. And that's 0.72, is that right? Fabulous. 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 What do you do to get P all by itself? Pretty simple, right? Don't we just need to get rid of this times e to the 0.72 by dividing both sides by e to the 0.72? So P equals 10 G's over e to the 0.72 power. Punch 'em. 10 G's divided by e to the 0.72 power. What would you round that to? Yep, it's money. So 4867 point what? So help me with that again. 4, 8, what? Yeah? Now let's punch that in and see if we'd still get 10,000 bucks back. All right, that's the number we got. I agree with you. Would you really get 10,000 bucks if you punched that in? So we're going in like right here. All right, we want to see if that equals 10 G's. So don't use the number that you have that's not rounded. Use the rounded number. Punching in 4867.52 times e to the 0.72 power. Isn't that what we want? Did you get $10,000? Nope. So how much would you really have to invest? Did you invest enough? Yes or no? So what do you need to invest? $4,867 and what? 53 cents. This wasn't enough to get you 10 grand because of rounding. Because we rounded it, we didn't make enough. So we didn't round. Sure, we rounded correctly mathematically. Realistically, it's got to be rounded up. So here's what it says. Her grandparents must invest $4,856.53 for her to have $10,000 after 18 years. Now this is the last one that I want to do because of time purposes. But see, this is such an interesting problem. We should add 2 words in here to mine. At least. That's really what needs to be in there. If you didn't have it, just put the arrow, same thing that I did. At least. Because here's what happens. I know you're a baby when this happens, but usually there's a check written or something happens, and your grandparents are going to put this money away. Do you really think that your grandparents are going to say, wow, let's set this up for Angelina. Let me get $4,867.53 put away. You think they'd put that weird number away in the bank? How much do you think they'd put away in the bank? It depends on how you're on. Some people will say $4,900. Some people will say $5,000. You know, it's like usually we'd round to the nearest 1,000 or to the nearest 100 or to the nearest 50 or something like that. You know, it's like that is just a ridiculous amount to specifically put away. But that is the minimum amount needed to get the $10,000 that they need. Does that make sense? If they put anything more than that in the bank, she'd still have her $10,000 18 years later. She'd have a little bit more. Make any sense? So please put this number for your answer. You got to go back and check to see if it works. Like that didn't work, so you might have to round it up. Sometimes it does work. Sometimes it doesn't work. Cool? Punch it in, see if it works.